are picking up, this is part 2 of our first lesson in pre-algebra. And we got down to this slide yesterday, which I've already cleared and erased, but we did this one yesterday. So yesterday we talked about rational numbers. What's a rational number?
It's rational. It's a ratio.
It can be written as a ratio, as a fraction. That's right. So any number that can be written as a fraction is a rational number. And we are going to turn a certain type of decimal into rational numbers. What type of decimal?
Repeating.
Repeating decimals into rational numbers. So turning terminating decimals into fractions was pretty simple. We saw in a couple of examples. But then when we got to repeating decimals, there was an algorithm we had to use, and it takes a few steps. And that can be a little bit confusing, but you guys did really well with it yesterday. So I know some math teachers don't like shortcuts, but I do when we can find them. So I showed you a shortcut yesterday. Remember what that shortcut was?
When it's 1 digit, it's 9.
There it is. We saw a couple of examples. There we go. Okay, so our first example was 0.5 repeating, and we saw it was 5 over 9. Then our next example was 0.4 repeating, and we saw that it was 4 over 9. So then we hypothesized, right?
Yeah.
We predicted that 0.2 repeating was going to be 2 over 9, and then we came over here and we did the math and we showed it. It
That's
is
awesome.
2 over 9. So we kind of found a little bit of a shortcut, but you still have to do the math, right? You still have to be able to show it and prove it. And so we talked about 1.1 repeating would be 1 over 9, and 0.3 repeating would be 3 over 9, but you have to simplify. Did we talk about 0.9 repeating?
Yeah, it's 1.
Okay, so I couldn't remember. I didn't do that in every class, but 0.9 repeating ends up to be 9 over 9, which is the same thing as 1. So 0.9 repeating really is just 1.
Yeah.
Yeah, and we talked about, you can win a bet with your parents on that one or something. So,
Yeah.
all right, so prove it to them. And that'd be a good way to remember how to do this stuff too. All right, so that's the steps. And then we ended on this slide, and we did this where the steps were kind of the same, but the answer comes out a little differently because now we have more numbers behind the decimal than just that repeating part, right? So that throws our answers off. We don't have that shortcut that we had. We have to do the math on that one. Okay? All right. So that's a quick review of what we did yesterday in part 1 of the lesson. Now, we're just going to pick up and do a couple more examples. And then there's like two or three more examples that we're going to do, and then it'll be time for your assignment. Woo-hoo. And you'll have some class time to work on that. All right? So, write the repeating decimal 0.63333 as a fraction.
Where is that?
So this should be middle of page 11, I believe.
Yeah, I
Is
see
that
it. I see
okay?
it.
Right in the middle of page 11. So we have a problem here, 0.63333, and we're going to start by doing what?
Yeah.
X equals 0.63 repeating, right? Okay. And what's my first move going to be now that I have my equation, Emery?
Multiply both by 10.
Multiply both by 10. That's exactly right. So 10x, and that when we multiply by 10, it moves that decimal over once. So 6.3 repeating. Next move.
You're gonna subtract.
Subtract
60/30.
There you go. I'm going to subtract 0.63 repeating. Subtract that original value, and over here I need to subtract x. So 10x minus 1x is 9x. And on this side, the repeating part drops out, which is what we want. And here I would have a 3 minus 6, which I can't do, so I have to borrow, right? Remember doing that? So 13 minus 6 is 7, and 5 minus 0 is 5. So 9x equals 5.7. Now what? Divide by 9, So x equals
something,
5.7 over 9,
but
but
we can't do that.
we can't do that.
That's
Can't have a
bad.
decimal in a fraction.
So how do you change it?
So how do we change it?
Hold on. I gotta look at the notes. I didn't write this down, my bad.
It's okay. If I don't want that fraction there, or that decimal there, sorry, what can I do?
Oh, you add.
I need to change the place values, so multiply both of these by 10. So 5.7 becomes
57 over 90.
57, so x equals 57 over 90. So I'm
That was awesome.
I'm simplifying the fraction is what I'm doing. This is a complex fraction, we can't have that, so we want a simplified fraction. Now, simplify again. So 557, what's a number that goes into 57 that also goes into 9?
That's a good question. 3.
3. So 57 divided by 3 is 19. 90 divided by 3
30.
is 30. 19 30ths.
Can't 3 go into 9? No. Okay.
I mean,
I thought it could.
yeah, I think I'm right there. Is
Yeah,
that good? Okay,
You're
19
right,
30ths.
you're a math teacher.
All right. Well, I make lots of mistakes though, and I love it when you guys catch my mistakes. I'm always happy when you tell me what I did wrong. Okay? All right. So that's basically just like the example that we did at the end of class yesterday. It's very similar to that one, where we still just have one digit that repeats, right? But we have more than one digit behind the decimal. So it throws off how our answer comes out, but we still just multiplied by 10. But what about our next one?
What's 209 as a mixed number?
So a couple things are different about this one. What's one thing that's different?
I feel like the end goal would be 209. Or
Oh.
900.
Okay, hold that thought, Emery.
Well, it's got 1 in the ones place.
Okay, so we have a number besides 0. We've got a value in the whole numbers place, right? That we have to deal with, we have to think about. We'll talk about that in just a minute. What's the other thing that's different about this one?
There's a 0 for a
How
9.
many digits repeat?
2.
2 digits repeat this time, and so that's going to affect what we do, because now we have we have to get rid of 2 numbers that repeat, not just 1. So we've got a couple of extra steps in this one. I'm kind of okay with shortcuts when we can find them, as long as we understand why they work.
There's a
And I'm
shortcut
getting,
for that.
well, there's one little shortcut that the book does a little different than what I want to do, but I want to take out a step or two. Okay, I want to make it a little easier on us. Is that okay? All right. So let's leave this alone for a minute. I'm going to a new example. You with me? So let's change this number, 2.25. Let's change that into a fraction. What is that going to be as a mixed number? Instead of a number with a decimal, let's do a number with a fraction. So
that's-
Emery.
2 and a 4.
Okay, 2 and 1/4. So notice what part of that stays the same.
The 2.
The 2, the whole number has to stay the same, right? So if I have a 2, that's my whole number, and then the 0.9, and what part of it am I changing into a fraction?
0.9.
Just the 0.9. I don't have to worry about the 2. I mean, this isn't going to be 3 and 4/7, is it?
No.
It's not going to be 5 and 9/16.
Yeah.
It can't be. It's got to have a 2 as the whole number. You with me?
Yeah.
So all I'm going to worry about is changing the decimal into a fraction. Your book wants you to leave this as part of the whole thing and work the whole thing out. And it just adds steps. I don't understand why we would do that to ourselves if we don't have to. If we understand that it has to stay the same, we just leave it alone. Does that make sense?
Yeah.
Okay, so I'm gonna take that part out of it so that we don't have to do the extra steps. But the problem with leaving it off as we work through it is when I get to the answer, I have to remember to put it back on there, right? So I'm gonna come over here and I'm gonna say x equals 2. And I'm gonna start there. And now I just figure out the fraction. When I write down my answer, I remember, oh yeah, I can't leave the 2 out. I've gotta have the 2, okay? I actually did this second hour when I went through this. I forgot the 2 after I went through this whole thing.
Don't forget the 2.
Okay, don't forget the 2. All right, now, so this starts out the same way we would do that one. But what's different?
It's not there. There's 2 digits.
There's 2 digits, and if I only move the decimal over one time, and then I take away 1x, then my repeating fractions don't line up. And I would end up not subtracting the number that I want to subtract.
Right.
Okay, I wouldn't get rid of the repeating part of the fraction. So I can't just move the decimal over once. So what am I gonna do?
You're gonna move it over twice.
If 2 digits repeat, I need to move the decimal over 2 times. So what do I have to do to move the decimal over 2 times? Instead of multiplying by 10,
100.
I'm gonna multiply by 100. So this would be 100x equals 9.09 repeating.
Yeah.
Okay? Now, everything else is still the same. Same steps. It works out a little differently, but it's still the same steps. What do I need to subtract?
Oh, you need to subtract 0, 9.
I need to subtract the repeating part.
Yeah.
So I'm going to subtract 0.09 repeating. Okay? Now what do I need to do?
You
What?
have to, it's 99x now, and push this 9
99x equals
9.
9. Because I subtracted this part, right?
You divide by 99.
Divide by 99.
That equals 2 and 1/11.
Okay, so the fraction
Don't
part,
you divide by 9 instead of?
1/11, yeah.
100 minus 1 is 99. So you would divide by 99. Yeah.
Okay.
Okay? So here I got the fraction part is 1/11, but up here when I write my answer, it's 2 and 1/11. Okay?
Yeah.
Elliot.
Right there where you subtract 0.09, why don't you put the 2 there?
Huh?
Because we're leaving the 2 out because the two never changes. So I'm going to drop the whole number off my equation and just not worry about it until the very end. Okay, that's why kind of when I was doing over here, the 2 and 2.25 has to be 2 1/4. So really all I have to do is change the decimal into a fraction. I don't have to change the, I don't have to worry about the whole number. So does the book go through this one step by step?
Yeah.
Okay, and in the book, they leave the 2 as part of the equation. But when you get down to the end, you still have that 2 that you have to simplify. Okay? And I'm leaving it out to save us a step. That's all I'm doing. I'm trying to make it easier, even though I don't match what the book says. It just kind of, I feel like it saves us a step in the end. Okay?
This is fine.
All right. Well, I'm glad you like it. So, let's talk about this one. I think this is down at the bottom of page 11 probably. Try it.
Oh, dude, really?
Repeating decimal 4.1363636. So, what number are we going to ignore for right now? 4. So I'm going to come over here and I'm going to say my x equals 4 and some fraction, right? I've got to have a fraction to fill in here, but the 4 has to stay the same. So I'm going to leave it out of the equation because I know it can't change. So all I'm going to solve is x equals 0.136 repeating.
But you have to times this by 1,000.
Ooh, how many digits repeat?
Oh, 2.
Still only 2 digits repeating, so what do I multiply by? 100. There you go. So 100x equals 13.636. And notice where I'm putting the repeating bar. The
Not
repeating,
above the 1.
I would not write it. We would not do this. We would not do it's 13.63 and then put it like that because that gets it out of order. It's not 636363. It's 363636. And those are 2 different numbers, right? So we can't put the repeating bar in the wrong spot.
Yeah.
Okay. So, all right. Now what?
You gotta subtract Stop laughing at me. My words don't come up right all the time.
That's okay.
36 repeating.
136.
136.
We have to subtract this number. That's what x equals. If we're
Yeah.
subtracting x, we have to subtract this number. So 136 repeating. That's the end of first lunch already? Wow.
Yeah, I missed
That's
Okay.
quick. All right.
I think the Bowery's at 33 or something.
Okay. So we'll subtract all of this. So that's 99x equals, that part subtracts. So it would be 13.5.
5. Yeah.
Is that right? Okay. Divide by
9.
99.
99.
So x
How
equals
did you get 99?
100 minus 1. It's okay. It's all right.
That's like Mickey Mouse Mason.
Hey,
Okay.
They're offended.
all right. So 13.5 over 99. But what's the problem? Can't have a decimal, so we've got to work that out. So we need to move the decimal over.
That's 135.
135 over
9.
990.
990. Okay. And then that would simplify, and I'll help you out with this one. Both those numbers will divide by 45.
That's wild number.
And so 45 goes into 35 3 times. And 990 divided by 45 is 22. I couldn't remember what that one was. So 3 over 22. So my answer is 4 and 3/20 seconds.
That's awesome.
Okay? All right. So at the end of each chapter, or the end of each lesson rather, they always put in this little review deal. This is one of those, I put it in here for us to look at just because they put it in the book. This is one of those things where if you were like on a desert island and the only way you could get off that desert island was by teaching yourself math out of a book, and this was all you had was this description, I'm probably stuck on that island the rest of my life.
Yeah.
Okay, I gotta be honest, I understand it now that we know the steps. Okay, our first step is always give a variable, right? The x equals that repeating decimal. Then we write the equation, the variable equals the decimal. Then we multiply each side by some power of 10. So we either multiply it by 10 or 100 or maybe even 1,000, depending on how many digits repeat, right? Okay, so subtract, we either subtract 1x, is what we subtract 1x from the left side and that repeating part of the fraction from the right side, and then we solve it, we divide. So I understand all those steps, but if this was, like if we started with this and I was like, okay, here's your description of what we're doing today, now do it, we're all sunk, okay? So I'm not in love with this, but there it is. And let's see, let's work through this one. No, not even that one, I don't like that one either. Let's work through this one. Let's do one more example and then I'll give you your assignment, okay? So what number are we ignoring?
2.
2. So we're gonna say x, or my final answer is x equals 2 and some fraction. Okay? So as we solve for x, we're gonna say x equals 0.318 repeating.
Okay.
What am I multiplying by? 100, good Riker.
Yeah.
So 100x equals 31.818 repeating. And what do I do next?
You subtract.
Minus x and minus 0.318 repeating.
I gotta write all this down, man. All in favor?
8 minus 3 is 5. So 99x equals 31.5. Divide by 99. So x is 31.5 over 99. Now what?
You gotta do,
Oh, you gotta
you
multiply
gotta
it by 100.
times it by 100.
Oh, no, 10.
By
sorry.
10, yep.
10.
We're moving the decimal one time, so 315 over 990. And I honestly am not, sure what common factors we've got. 315 divided by 15 should go into both of them.
21.
21, and then 990 divided by 15 is 66. So we're still not done yet. 21 over 66, that would be 7 over 22.
You did that in your head.
Numbers make sense to me. Okay, all right. So,
Come on, 22.
all right. When there's a blue slide at the end, the blue slide has the assignment. So your assignment's pages 13 and 14 in your book. You've got, I think 28 is when the bell rings, so you've got a good 10 minutes, 11 minutes to get started on that assignment. Don't forget that you also have 2 assignments that are due by Friday. The glossary assignment and the pre-test for chapter 1. And tomorrow we're doing FastBridge, so bring your Chromebooks charged, bring your math books so that you can work on this assignment after you finish FastBridge.